everyone. I'm Engineer Abubakar Lawal, Civil Infrastructural Design Manager at Infraworks Engineering Services Limited. The last virtual exploration section we had on using Autodesk Infraworks and AutoCAD Civil 3D for design and documentations of roads and infrastructures and some other infrastructural utilities. On March 16, 2019, we have these sections, but due to poor internet connections and some constraint, we couldn't have a complete recording process. But now I'm giving us an overview of the process of using AutoCAD Civil 3D and Infraworks together as a tool for infrastructural design documentations and infrastructural design review and update, and also for producing your construction document. Today, I'm going to use these two software to explain the workflow for a project, taking a case studies of a street road of about 1 kilometer as the first case studies. The second case study would be an infrastructure project for a 1 kilometer distance of a road that has bridge components. But to start with, we need to explain the procedure in working with AutoCAD Civil 3D. AutoCAD Civil 3D is one of the most versatile and user-friendly civil infrastructural design software that allows you to do your complete design and at the same time do your detailing functions. Detailing can be programmed in such a way that at the end of your design project, your detailed work output can be saved as a template for you to use for another project. So if you have your template, it's easier for you to do your detailing as fast as possible than using the other normal conventional methods. Now to start, I will start to introduce us to the basic interface of Civil 3D 2019. This is a licensed product. For the purpose of integration with Infraworks, the first things you need to do in AutoCAD Civil 3D environment is to coordinate your project. When you look at this is the tool space. It has the perspective tabs, the settings tabs, which you can use to do these coordinations. And you have all the ribbons that you work with and some AutoCAD functions. So in this case, we can now decide that this kind of project I'm working on needs to be open in Infraworks. So I need to do a projections by editing the drawing settings to give me a data projection with the coordinate system I'm using. In this situation, it means that you must reference your data with a specific coordinate system positions. In this case, I'm using Nigeria as a case study for this country I'm working on this design. So I put it as such. I have Nigeria, and I select the zone closer to my locations, ENA UTM zone 32. So I've given the projections. Most of the time, the drawing setting is always in scale 1 to 1000, that is in meter unit. So you can see these are the projected. You have this. But most time, people, when they use survey data, we don't give it any data or projections, any data or projections of the coordinate system. But for you to integrate with Infraworks 260, you must have the projections and it must be stated with the reference coordinate systems. Now, the first thing I'm going to do is just to quick explanation of the process of the workflow. Just do a quick overview of the workflow processes. So in Civil 3D. Now, I open a drawings, but at the same time, I said if you have done a design project before, it's easier for you to use the template for that project so that you will not be doing much of detailing. So for instance, now I have worked on some project on this Civil 3D interface. So I don't need to start with the raw interface because it will give me the descriptions and detailing in the form of the default settings. But I don't need that because I need to work as fast as possible So what I need to know is just I need to open a new drawing with the template of my previous project. Click new, then I have the template. This is my official template. I click on it. So with this template, I have a coordination information as described, even to the extent of my detailing for my cross section has been stated. You can see this is a template I normally use, but it can be modified. So then what I need to do next is to go back to my information source. Now, I said I'm going to explain this workflow with two simple case study projects. The first one, we're explaining a location zone in Kuje. I was going to have it as a 1 kilometer distance, showing the reference from the drawing we have here. There is the site I'm considering. There's a map. You can see we have this road extensions of 1 kilometers. There are some offshoot access roads, and you also have the feature lines for the flood flow lines. That means this road will have drainage facilities because of the slope, and this drainage facility will be diverted at these brown locations to take it to the stream level of the water in these directions. So the purpose of the design is to explain the process of having the road pavement structures and having drainage controlled by the slope and the direction where you're going to put your culvert, and at the same time where you're going to have your access culvert. So we're using this as a case studies, and how you can translate this information from your Civil 3D design environment to Infraworks. So we're going back to the project. So now, from here now, I have set these parameters with my reference based on the project I opened just now. Then with my own template, the first thing I have to do is to click on the point and import the survey point. If I'm working directly from Civil 3D, I can import the survey data into it and do my design. At the end of it, I have the surface of the design levels and the existing, and I export it to Infraworks. We explain the procedure, and at the same time, I can work from the preliminary point of view from Infraworks directly. It means that I can use the location of the environment I have in Infraworks to coordinate a preliminary design on that site for a quick review of the horizontal and the vertical profile. So it means whatever you can do in Civil 3D, you can as well do it in Infraworks as a preliminary design process later, which you can come back to your detailed design in Civil 3D. So the integration of these two software is infrastructure is essential for us in defining the term BIM for infrastructure. So we still have more to go. So let's continue. So yeah, we're working directly with the survey data. Right, and I click on create data. The next is I want to import data. In most cases, you already have the established survey data. I click on it. Next thing, I go to the particular format that it will save. The format, select the format and a space delimited or import the data for us. Where's the data now? I import it is an Excel file, say as .csv file. So look at the file. This is the data. I load it, then I'll set the appropriate format. This is it. So it has point number, nothing, easting, elevation, and descriptions. This information is very important. When you have your Excel data, it must be arranged in order of presentations. In most cases, we will have the northern, eastern, and the point elevation as what most survey always give as information. But for construction design management and construction management, it's good to always attach this with a point number, which you can create a column for it in Excel. And at the same time, it's always good when you are working on a critical terrain for the surveyor to give you the information, to give you the descriptions of all information regarding those sites. So it's very essential. Now, the next thing that I've set a particular format I need, which is PNEZD. I load the data into the Civil 3D interface. The next thing I right click on it, I zoom to it to see my points. You can see this is the point I have. I can decide these are the point figures. These are the description details of it. At the same time, I can just remove those descriptions. Yeah, I can remove those descriptions. Uh, Search. Right click. You click on point group properties. We can have no descriptions. Then the next thing is to coordinate this point with the surface. Without the surface, you cannot start any design procedure. So click on the surface from the prospectus, create surface, then give it a name that is, let's say, Zar road surface. This surface can be Zara road existing surface from the data we have. Then we create that. Then we come to the surface that we created, that Zara road existing surface. We had the reference definitions, we had the figure, then we had point. When I click add to point, we write all points, then we click, then we apply. So we have this stated. So this is the details I have. Now, in order to create your alignment, we have two options, because alignment is the definitions of the reference positions of your corridor takeoff. So the alignment is the reference to all kind of information you need. So you are talking in terms of road, your reference alignment must be defined in line with the design criteria for each country as specified. And at the same time, you can have references that connect your training infrastructure. It has to be defined and follow the process of design criteria. So in this case, we are assuming that we're going to have a reference of our alignment to define the center alignment that's going to have a pavement structure of 3.65 as the normal for a single carriageway, and it's going to have the drainage infrastructure by the side. So that's what we're considering. So this alignment, central alignment, will be the information to build our assembly and corridor. So it has to be referenced as such. And to create your alignment, what you can have it one as existing polylines that define the alignment as an object. So for instance, in estate development, they already define the layout, define those lines. So those lines can be used as an object and convert to alignment. And also you can create an object for yourself. But if you are working on terrain where you don't define such, then you need to specify alignment creation to define the road alignment with respect to the design speed, and you have to follow the criteria standard. For instance, in Nigeria, we make use of the Federal Highway Design Manual, Volume 1 on geometric design. The parameter stated is what we're going to utilize on this project. And for this project, what this 1 kilometer distance road is a street road, and this design speed is between 40 to 60 kilometers. If you have that reference, I think you can always check the Federal Highway Design Manual as reviewed in 2013 as stated. So, but in case we are using the design speed of 60 kilometers for this kind of design, so I'll set the parameter to 60 kilometers. And since I'm using our criteria, I'm not using the astro. So I click on the proposed road and give it a name for the alignment, and I define that. So the next thing I go to that from the alignment label to layout tools, I define to set my curve and spiral settings. Remember, when you choose a design project of 60 kilometers, the default radius, which is also the maximum radius you consider, is 210, as defined in the manual. So we click at that. Then when you click that, it has given a reference. You now connect your alignment from the starting position, and the starting position have to take off from an existing road infrastructure. So we collect it, then you go down to the road. Just use an example. A time can be well defined more than this, but just want to explain the process. So in case I have curve, the information will define the curve line for me at default. So I don't have to change the point of transactions or point of change the information I have to define uh, the alignment for me. So I'm just taking to the key overview for this procedure. So we have the endpoint here. You can see escape. So all information will be stated here. You can see now the detail you have here is from the default, but since this is a template, what I need to do is to do edit alignment labels and delete all information I have here and put my own template that is already there at as a major stations increment of 20 meters. Then I also put in with geometric points. These are the two things I need for here because not much. So I click on it, you can see it comes out directly. So I don't need to do much. When you look at the difference here, this is a settings for my template. I don't have to do much on this. As you set for the point and for the change. This one, nothing was set, is at default. So I can edit this as well, but that one will come in a later part of this project. So the alignment has been created on this existing surface. The next thing is to define the vertical information of this details, the vertical profile. So under the profile, I can create this existing surface profile under the add with alignment with the existing surface conditions, add it, draw in profile view, create it. I don't want to go much to that. So we have this is the existing alignment profile for the alignment. So we have this information. I click on this again. I can set my bands based on what I've saved. I can import band. I can have some settings that have been saved already. So you can define those bands. Click it as such. Give you some information you need. So that means I have all the information existing. I can convert this to design, I can convert it to invert level, this is the change, and this is the horizontal profile of the directions of the information. You can see this has been set. It is easier for me to coordinate this workflow. The next thing I will do after this is to now go to the design procedure to now design the processes of coordinating my vertical design process. As I said, since the design speed is 60 km per hour, for design criteria, it specified that the sag conditions would be 18 and the constant K, and also for the crest conditions for the constant K is 11, as stated in the highway design manual. So I'll come to profile to now use my profile creation tools, select the profile view, then and click on the design profile and set the parameter for the curve settings to state the exact crest curve for K value to be 11 and the sag to be 18 as defined from the manual. So I click it. The next thing I do these informations with draw tangent to curve to design. So in most time when you are using this, you have to balance between cut and fill to make sure that you have the information to come close to the existing conditions. Not at all. If you define what level are you defining, this information level is the count level, you define it as such, then you draw the lines, check it slowly because it's good. Now at this point, I'm going to have a point of vertical change. So I have it. So as I change it, the curve change in line with the informations. So here I can balance between cut and fill. Then I can say, okay, this to the existing levels is this what I have as final. So you can see I've defined my informations. So this has been defined as such. So you can see the steepness of that site. From here, you can edit any information you want to edit. Here, you can change it. You can move it. You can change it down, you can increase it, you can adjust it, but the adjustment will be based in conditions. You can see with this specified details. So information that's stated here, you can do editing from here. So we have that. Then I can bring in my profile for this information is existing. The design levels, I have it. So I can change my information for the design level, the layout. I can name it. I can see this. I'm using the surface one and define. At the same time, I can edit all the label templates from here under the alignment type profile and name it as this one is the count level. You can put it as designed levels. Yeah. So levels. So I can put it as such. I do it and refresh, generate the view. You can see it has changed the right levels. You can see. So the next one I want to use for doing inverse levels, and that can only be done after you created your assembly. So after the design levels has been created, you can see now it has been created and the information is stated. The next thing you need to do is from this information you can get what you have your alignment data. And how do you get the alignment data for this project? To define the reference positions, you just click on the alignment. Oh, let's say alignment, annotate alignment labels. You have alignment, then you set multiple segments for this alignment. When you click on it, the segment will come in, show the direction, position, show the lines, show curves. Then if you've gotten that, then you can now convert it to a table file. You have alignment, has segments, then segment file will come in, alignment data, then this. I'll program all these informations for myself. So when I click on this, it gives me the alignment data. So it's easier for me to reference this alignment perfectly on the descriptions. You can see these alignment data. When an alignment data, based on the label, as you can change it, you can see changes, the existing positions, whether this is a line, you have a line, and the segment, the length of the line. When there is a curve, it's giving the existing settings for the maximum radius I can have because it contains it. And lesser than that, and everything has been defined. You can see that's an editor. These are the program. So if you truly allow, I can program this to have this information. I can program a lot of things to show in my limit data. So it's very good for describing details. So in the architectural engineering construction, it's very versatile to use Civil 3D from design process and also for construction management. So these are the things that features you can easily have and you can relate with your teams on site. The next thing is to define the assembly for these informations. The assembly data we have creating the assembly form to create the assembly, then the assembly to define our information. So I'm creating another assembly now as maybe assembly Zara code assembly. So I have it and define that. So this is my reference. The reference line take information from the design profile levels. So if you design assembly, you use what we call two pellets. Two pellets give you the information you need to manage your work. And the two pellets is under this place. You can use it. You can see for the information you have here. And so I have the two pellets for this. So my two pillars, I consider those things I want to work with, which is basic, it can be lanes. So lanes, you have this. I specify, assuming I just have a lane without a median, then I'll specify the description of that lanes. Or with this one, the standard of a single corridor is 3.65. I have a slope of maybe 2.5 or 3%. Then I have a pavement structure of, if you have wiring cost, depends. You don't have wiring cost, you put, if you don't have binding cost, you put the wiring cost information you have. Maybe the wiring cost is 50 mm. Then I don't have binders, you put it 0 if you don't have that. I have the discs, maybe to be 150 mm. So this thing can be set in line with your pavement design informations. You have to program your pavement structure details as such. So we have this. Then away from crown, yes. Pivot position. We're having possible elevation. It will be pivoted. Yes. We don't have it. You can leave it as that. Crown level shown at both ends of edge of pavement line. So I have for the right, I click it for the right. For the left, just a matter of changes. For the left, I change it, I click it to the left. I have this. You can see it has been defined to the left. You can see as I define it, give me the levels, the current position levels. But this has been detailed already because I'm using my existing template for the elevation at this and also the extent of the offset 3.65 and the elevations at that distance, what it's going to be. So it means that with this information, whatever I build out, the final information, the cross section intervals will show those current levels. That's why I have it in my profile levels. I can also have it in the cross sectional levels with respect to the cut and field informations. I think before we finish this, we'll see the trend of what I'm saying. So the next, I've created assembly. The next thing I'll go on is to create the corridor. No, maybe I need to create, remember I said I create a unit structure that comes after the pavement structures. Then I come to channels. With channels, this channel, train pipes, solar pipe, I come to channels, solar channels. I'm having U drainage channels, side drains. So I'm having the depth to be maybe the depth to be 0.6, and at the same time I have the bottom width to be 0.6. These are end-to-end information descriptions. For side slope for a U channel is a 0. The lining depth, that is the thickness of the walls, is 100 mm as used. Then why I don't have this in a build-out area, I don't have any kind of offset from any directions for a build-out street road. So it just terminates at the drainage, all information refers to it. So I get the information, I put it where I want to locate it. The other time I put it as such too. So I have the drainage. Now to put it at the exact positions, the drainages are what we call the ribbon, the connecting line for each sub-assembly information. You can see it move it, connect those line, the connector, this now to position it to, to match on the sub-assembly details so I can have your assembly information. You can see it as reference at the edge. So every other information can be built out as such. But we're just using this to explain the simple procedure of working with this. You can see. So this is my assembly build-up with detailed informations. So at this point, I need to can get the invert level for my drainage alignment. You can see I'm using this simple. Yeah, I can have this. That is okay. And go back to this. Now at the same time, I can take you back to some assembly that has been created in this project template. Now assembly here. As in this district, let me show district collectors road. Zoom to another. This is another assembly I have. You can see it stated the levels of what I have, stated all the position of some underground infrastructures, and I say I have the pavement. I have this one. I can see stated me the what we call the median, the curves. I have the pavement structure, define the structures in terms of what I have detailed. I have the information for the edge, that is the edge of the pavement, where it's going to ripple along this line with a specific ripple intervals, and I also have the walkway edge, and every details are stated. You can state more details at this, just an example, and this can be shown in your cross sections as intervals. So the next thing that we're going back to our corridor, and going back to this route, this is zone 2. We will have now this assembly I'm using. It has those the pavement structure and the drainage. So the next thing to create the corridor after your assembly, a corridor, I give you the name, which corridor for Zara Road corridor, give it a name, then alignment. We have the alignment, design, we are using the profile design levels, assembly, Zara Road assembly, target surface, existing surface, click on it. After click, you have this, you press build corridor, the corridor has been defined. Then you say the corridor. The next thing you zoom to this place, you have the information as stated. Now this is the default settings of this, where I can change the order of arrangement, set these parameters to choose, use my corridor properties, then come to feature lines. Then the one that I don't need, I remove them. The sub, I don't use the current sub base sub. So I need the current level, I don't need the pavement, I need top flow line, I need this. So I can change the corridor information for this. That is for the top flow line, you should have the basic curved lines, corridors, can describe for the channel flow line and set parameters to have my corridor flow line patterns. Then this, I don't need this, then I can just describe this. So these informations are going to define, show me that this color code in purple is the invert level. This is the end into end of the drainage, and this is the pavement line for the center line and the edge of the pavement, you can see. And this interval between it is the thickness of the wall. While the end of the wall, if you say end of shoulder, you should not show the details, can show other details as well. So now after that, I can come to surface. You must create what we call the corridor surface, and you have to give it the projections. What projection are we using? You are using the datum 4, refining it to projection. So datum, in case you verify where you have to cut and fill, to take the datum information, the reference you're choosing line with the existing condition. It's well stated. So with this, you have that, and if you are defining it with terms of the top versions, it depends on how you program your assembly informations. So we have this in place build, you have the corridor build up as stated. Then the next thing you're going to have is to create what we call, we have created a surface, corridor surface now. So what we need to create now is to create, okay, I've created a lot of it. I can now create a profile for this invert level now. What I do, I'll now click on profile, create profile from corridor. I'll now select this the invert level lines and give it a name, maybe drainage invert level. So drainage invert levels. So I have it. I can use the layout. Yes. So I have it. So I've created that. Then you can see when you cancel, the a flow line has been created. So this can come under. Sorry, whatever we have is load that the line of terminations was defined. So it has to be redoubled to show this. What you need to do is just move the PBI because it's an overshoot of the information. You just remove the PBI information for this. I take this to sorry because it's an offshoot from DNA. It's not defined from the criteria, so you have to take it out to align with the finish line. Sorry for this. Just use this. Just put it with the same line to change. Sorry, sorry for that. It's just the thing was going beyond this, so you have to solve it back. So now I can put this. You can see the invert level line is shown. I can put it under this. I can now create this under the free properties. I select this. Then I can select my unit invert levels. I click it. So I've put the unit invert level to it. Very precise. You can see this is the unit invert levels. I have the existing, the design levels, the unit invert levels, and the change and the local geometry. So as been stated. So the next thing I want to coordinate the sample line informations, or what I will need to do is to put this, create a sample line for this project. Create a sample line, click on sample lines, select the alignment I want to create to coordinate my cut and fill informations, give it a name, you select those items you want. For the corridor, you are using all code style for the corridor sections. Then the corridor will have the finish ground. Set these parameters. Then when you set it, you can just have it, press OK. Then you click the range of station you are considering, that's the entire range of station for these items. So you have to click that. Again, sample lines, select the item you want, click on it. The range of stations, yes, we have this. What range of station do we have? So we can let us put it as 5, just to show the offset side of that locations. Then the changes are 20 meters intervals. Take note, either 20 meters intervals, it must correspond to the alignment intervals. So I have this status informations here. So the information has been defined. Accurate. Let's do it again. So sample lines, this, select the things you want, barcodes, finish ground, load this. I have this window stations, set 5, 5, and these are 20 meters intervals. Then you have this. Then click on this. Okay. Then escape. Then that's shown. Then here at the same time, at the interval I've shown, can edit the labels. I've already defined everything. They do the labels. I remove this style. I have my own design which have been done. For detailing, the cut section you can see at this interval. So I have this information now showing and cutting in at these intervals. So I can remove this, doesn't obstruct my information. You can see this is a line, I can edit this information. I can even remove it from. So here now I can click on this, not show the lines again, or the sample line groups. I can remove this, not showing information. You can see. So these are sided line offset. It covers the extent of the corridor. You can see you have some offset to define the existing so that how the line will come back to the existing structures. What did you do side? So I have my corridor sample line has been defined. After you define your sample lines, the next thing is to come up to that sample line collection, define the properties under alignment, select the criteria of functions for cut and fill, then existing ground is the surface, then the datum is the corridor. Then you click on it to get the details. So from here now, I can get my basically the volume analysis report directly. So to do this, I can just click on the tables. Then I have for these details, I have the volume tables. So it's giving the volume, the cumulative, the field volume, the cut volumes, and I have the cumulative informations as regard this project. So you can see this done. So the next thing to do is to now move on to the next. After you create this, you will technically finish your details. The next is to create sections of your functions. You create multiple sections at intervals, collect it. You have the template to define it. It's next. Then you select what you want, what you don't want. Then you next. It is a staging ground. Then you select for the staging ground, set it. This set it sets. Then next. Then we have this volume tables. The spacing between the sections and the volume table 40 mm. Then select the total volume tables. The material remove, then set, then set it. Then you can create your section for this information to show with sections. So what I'm saying that you can work with sections for precise coordination. You can see these volume, these sections, you can adjust this, and this is the volume tables. This is the ground remove information can be set in full. You can see we have cut and fill. When you have cut, red. When you have fill, is green. So everything along the 2 inch interval, 20 meters interval, you're having the levels. Something that you have the level. You can see. Take an example now. 220. The center line ground level is what? 293.465. Let's check the profile. So 320, you can see. And so these are 25 meters intervals. So we change it 20 meters intervals. We have 20. So at 220, you can see the same thing. Is it. So you can decide to work the profile and can decide to coordinate your information with the cross sections at intervals and to state it and give information for cut and fill at that instance. So it's good as that. The next thing is to do a profiling. If you do a plan and profile, you come to output, productions, plan productions, create frame. The frame you create for this, define along what? Along alignment, create along alignment. So you select your template. You can define this in your A3 template, A1 template, and select it. Let's do A not template. You have it 1000. Yeah. You click on next, then give it a name for the view frame group. Maybe you leave it as such. Then there's a lot of things you click on. There's the one to match line to show. You hide it off. Then click the view frame for this. So this is just a 2 view frame for this project. So I use a A1 sheet size. So the next thing is I come to create sheet. Then I can create sheet for this. The only drawings I can make it be on the same pattern. Show the reference arrow. Then what next? Create sheet. Then you have the sheet created. Okay, I've not seen this project. I can see it as Yeah. So create sheets now, creating the origins. So the sheet can be created. So these are basically to explain the overview of using the basic tools in Civil 3D to arrive at a finished product in terms of the design clear levels, in terms of having your complete section view at intervals with the artwork information details. So at this instance, if I want to review this work in Infraworks and get the information as details as built in Infraworks, all I need to do is to save my information as IMX from Civil 3D. If you're editing the profile lines, the vertical profile, you must save it as, export it as IMX to Infraworks. But you are okay with the reference, defined everything has been defined, you're okay with it, then you must save it as land XML. So that we're going to combine the two, export IMX file, yes, to project. Then exported. Then we can also export to land XML. You can see all the ones you need. You capture it for the land XML. If you need now, for instance, these are not editing, you just need the surface, you click on it. Then those things that you want to show in your information design level, yeah, daily levels, and you can allow it to show in your profile. So all those information you need, the one you don't need, you remove them. So check those ones you don't need. If you are saving land SLMX, all the information that you don't need, you remove it on the site. Then you don't need this corridor, you can leave it. So you can save as such too. Then this is HTML file. Let's say we have that. Then if you're exporting to Civil, after you finish your work, when you finish your editing, your sheet level informations, you export to also export directly to AutoCAD. So it doesn't have any kind of Civil 3D functions. But at the same time, you can finish all your work in Civil 3D. It's very easy for you to edit any items. It will edit on all. So one of the advantage of using Civil 3D is that it's very user friendly. You can easily modify any design informations and everything will update itself. And you can do your final production in Civil 3D interface. So we've done the conversions. Then just in a moment, I will show the procedure of using or converting, taking these informations Infraworks and work directly from Infraworks for the next sections. We're going to have a short timeout from here, so stay tuned while the second video sections will be uploaded for using Infraworks 360 directly with coordination for road and bridge design informations. At the same time, how we can now update those informations back to Civil 3D. Stay tuned.